55x squared plus 5,113x minus 54,448 equals 30,000. Okay, can anyone get us started? What should I do first?
Add 54,448 to both sides.
I don't want to do that because I will never complete the square on something like this. Can you? Yes, but it's a tremendous amount of work. So here I will not complete the square. I will never ever complete the square unless you bend my hand or force me, in other words. If you don't force me, I will never use the complete the square. Oh, no, no, ever. Is this factorable? Maybe, I don't care. I'm not going to work with these numbers. So if I don't use the complete the square, I cannot use the taking square roots. That's done. And factoring is done. So my only chance is the quadratic formula. So in the quadratic formula, I have to present everything, the equation in a standard form. If I don't have 0 on one side, I cannot apply the quadratic formula. So I will move 30 to the other side. So I have negative 55x squared and plus 5,113x. And I have negative 54,000 plus negative 30. So I have negative 84,448. The next step is never, ever solve a quadratic equation with a negative, or any equation for that matter, with a negative leading coefficient. Oh, absolutely never. So I would multiply both sides or divide both sides by -1 is the same thing. So 55x squared minus 5513 plus 84448 equals 0. This times -1, this times -1, this times -1, this times -1. Now this is the quadratic formula situation. So I'm not going to calculate it. I'm just going to put it in so you can see it. But I'm going to show you something else with the calculator. Negative b plus or minus b squared minus 4 times a times c over 2 times a. Yes, I have to calculate the whole thing, and I will put parentheses around the numerator, parentheses under the square root, and so on and so forth. I want to show you something else with the calculator. Not all calculators have this feature. If you want to borrow a calculator from the testing center, do so. If your calculator doesn't have this feature, it helps just to check your answers, because this will not give you the option. If the answer is irrational, you will not be able to change it into a fraction. So see next to math right here. So it's the second, the blue key, the green key, alpha, and underneath is math. To the right of it, there is a key named APPS. You may or may not have the APPS, but let's say you do. Click on it and select number 9. When you select number 9, you're going to see something called a polynomial root finder. This is a polynomial equation. Specifically, it's quadratic because the degree is 2 of the polynomial, right? But when you click enter, it gives you 10 options for 10 degrees. They use the word order. Why? Don't ask me. This is the degree. So degree 1, degree 2, degree 3, and so on and so forth till degree 10. In our case, it's degree 2. So I'll press graph. Don't ask me why graph and not enter. I have no idea. And now slowly but surely, I have to enter the coefficients, the leading term, the middle coefficient, and the free term in this correct order. So I have 55. And the next coefficient is negative 5113. Remember, when you start with a negative sign, you have to use the sign, not the operational sign. Enter. And then the last coefficient is this 84448. Enter. After you enter these three coefficients, 55, negative 5,113, and 84,448, then you click on graph again. Don't ask me why graph and not enter, I have no idea. And you will see the solutions. Okay, so it gave one solution as a rational number, and I have to calculate what, then see what that is. So the first solution is x sub 1, which is 21.48, and x sub 2 is 621,416 divided by 8,693. I have to see what this is. Second and quit, and 621,416, and divide by 8693. Okay, so the other solution is x sub 2, 71.48. So now, use a comma to separate answers and round to the nearest year. So nearest year for 21.48 is 21. And they want a comma, fine. And the other one is 71.48, so I'm going to put 71. And I check my answer. So this method works when I'm asked to round up or down whatever, like in this case, it was down. We rounded down from 71.48 to 71. This procedure works. What procedure? The polynomial root finder. But if they want the exact solutions, you can only check with the polynomial root finder. Any questions? It's a good feature to have. It's a good feature to have, especially available on a test situation, of course. Any questions? So we completed 8.6 and 8.7. Is there anything else that you would like to go back to? Any other type of question or questions? Any topic maybe? Sorry about that. Oh, it's from school. I have to take it. Yes, hello? Yes, speaking. One of my students is taking a test. Okay. In math 137. But I'm just very surprised by this because I'm looking at two other students who just took it.
Yeah, I'm not sure why. I'm looking at the process test. It says test 1, section T3, T5, 1.1, 1.2. It looks like the only option there. But then when I put the password in, it doesn't accept it.
But how is it possible two other students just took it?
I have no idea.
Okay, I will have to call you back. I'm so sorry. I'll call you right back. So remind me, the extension at Arundel Mills is 1916?
1915.
1915. I'll call you right back. Thank you so much. Thank you. How can a password work at one location and not work at another? My apologies for having to take that call. When the testing center calls, I have to take the call. So sorry. Okay, I will verify and see what happens with the student. I'm not sure. Okay, any questions, anything you would like to go back to, any topic from test 4 or anything else?
I've been going over the notes from 7 and 8, and I don't know, there's just a lot of different ways to get the answer. It's like you get, for one question, you get 3 different answers.
Oh no. Regardless of the method you apply, you have to always get the same answer. Do you have an example for us? That would be the best.
Well, just the question up there, the factoring quadratic equation or the square root. I mean, right there, there's 3 different.
Yes, but the answer has to be the same. Oh, absolutely the same.
Yeah.
Forever. No matter which method you use to get to the answer, it has to be the same answer. So do you want us to go to any example?
Oh, I don't know an example. I'm just saying that's for me, that's going to be the hardest part on the test, is just figuring out what question or answer I'm supposed to give.
Well, the answer will tell you, I mean, the problem will tell you exactly what type of answer you have to give. If it's an approximation.
Well, it didn't work that well for a lot of us on, test 5 and 6, so I don't know.
We don't have
same kind of issue there. I didn't know what kind of question you wanted.
We don't have a test 5 and 6. You mean module 5 and 6?
Yep.
So let's go to a problem because I'm not sure I understand the question. So let's go to any question. Do you want us to go to any of these, for example, where we selected the method? I mean, I can show with any of these problems that you can use more than one method, but the answer will always be the same, no matter what. Is that what we would like to go and look at?
No, I'm good.
I don't mind. I mean, I just want you to understand that the answer has to be the same. If you use factoring, assuming the polynomial is factorable, and I use the quadratic formula, we have to get the same answers on the same problem, of course. Do you want me to illustrate on the same problem with different methods? Will that convince you? Because if you're not convinced, maybe others are not convinced as well. So no matter which method we apply, we have to use. Okay, the testing center is calling me again. Yes, hello.
Hey, this is Tammy from testing office. We got it working. He
oh.
was in the wrong spot. So
Oh,
I was able to get the
okay,
right
okay. Thank you so much. Thank you for calling back. Thank you.
No problem.
Thank you. I
Have a good
appreciate
one.
it. Thank you. Bye-bye. Okay, problem solved. Okay, so would you like me to illustrate on a problem with multiple methods to see how we get to the same answer?
I guess I don't even understand my question, so.
Okay, maybe I do. So let's do this. So for example, let's say we have x squared minus 5x plus 6 equals 0. So this is our equation. Okay? And we want to solve this equation using all possible methods. Good or bad, it doesn't matter. We want to solve all using the same, using all possible methods. So this is a nice example because x minus 2 and x minus 3 is 0. So the first method is applicable, which is factoring. And I'm done. X equals 2 and x equals 3. The sum of the number is -5. The product is 6.
See, I thought it's positive 6, -1. So.
But the product is positive. So positive 6 and -1, the product is -6. Is not positive 6. So these numbers cannot work.
Oh my goodness.
And then 6 minus 1 is not -5. It's positive 5. So remember, we have to find two numbers whose product is 6 and whose sum is -5. Because the product is positive, both numbers have to have the same sign. And because the sum is negative, both of them have to be negative.
Okay.
So this is the thinking process. First, I look at the product. Because the product is positive, numbers have to have the same sign. The 6 and a negative 6 will not work because I will not get 6. But with negative 2 and negative 3, the sum is negative 5, and the product is indeed 6. So this was method 1. Now let's look at method 2, which is completing the square. So x squared minus 5x plus 6 equals 0. The middle coefficient is negative 5. I divide negative 5 by 2. I have to square negative 5 halves. And this is what I have to add to both sides. So I have x squared minus 5x plus 25 over 4. I have to move 6 to the other side. 25 over 4 minus 6. So again, complete the square. Negative 5. I divide negative 5 by 2. I square negative 5 halves. And this is the number I have to add to both sides. And I move 6 to the other side. It was positive, it becomes negative. The left-hand side, I have to see what we just talked about. Equals 25 minus 24, 1/4. So I use completing the square, and now I have to use the taking square roots. So method 2 and method 3 together. Completing the square and taking square roots. So have x equals, I'm sorry, I didn't mean to jump. X minus 5 halves equals plus or minus 1/4. I'm sorry. 1/2. The square root of 1 and the square root of 4. I move 5 halves. 5 halves plus or minus 1/2. I have to separate them. And I better get this. Otherwise, the whole thing is a joke. So 5 over 2 plus 1 over 2 is 6 over 2. 5 over 2 minus 1 over 2 is 4 over 2. So the first method was factoring. The second and the third, completing the square and taking square roots. And final method, quadratic formula.
So how'd you get the 1/4? Shouldn't it have been 5/4?
25 over
5
4.
seconds?
I have to multiply this by 4 because it's over 1. I have to find the least common
okay.
denominator. And 25 minus 4 times 6, which is 24. 25 minus 24 over 4 is 1 over 4. Is that okay?
Yeah.
Perfect. I'd rather go back and check. Sometimes I make errors. Everybody makes errors. I'm sorry, I'm not justifying. I'm just saying maybe you see something I don't. So when we take the square root, we get 1/2. The square root of 1 and the square root of 4. I move 5 halves. 5 plus 1, 6 over 2 is 3. 5 minus 1, 4 over 2 is 2. Finally, the quadratic formula. It better give us the exact same thing. Negative b plus or minus b squared minus 4ac over 2a. So this is 5 plus or minus 1 over 2. It has to be the same thing. So no matter which method you apply, you have to always come back to the same. Did I write 2? So x equals 5 plus or minus 1 divided by 2. 5 plus 1 is 6 divided by 2. 5 minus 1 is 4 divided by 2. It better be the same thing no matter what. Very good question, Rachel. You may have not known exactly what you were asking, but it was a very good question because I'm sure that others are wondering, okay, how do it doesn't matter. If a method is applicable, it will take us to the exact same solution. So on this equation, I cannot get 2, 3 as answers and somebody else gets 4, 7. That's not possible. No matter which method we apply, we have to come to the same resolution, to the same answer.